HVAC electronic expansion valve. The HVAC electronic expansion valve is yet another development of two modern automotive air conditioning systems. This is cutting-edge technology at this point in time for the automobile industry. The electronic expansion valve has been used in stationary commercial air conditioning for a few years now, but it has remained absent in automobiles, until now. It's been discussed in various standards committees and is making an entry into the automotive world. So, without further ado, here's how it works. The HVAC electronic expansion valve uses a stepper motor to control the valve aperture. A stepper motor is related to digital technology. It is a brushless motor, and works by the constant phasing or switching of four magnetic field coils. Here they're named coils A and B. Suffice it to say that stepper motors are used when very fine control is needed. They're used on CNC machine shop milling machines and lathes to make accurate metal parts, among other applications. This is the reason why they're also used in the HVAC electronic expansion valve. The HVAC head or computer controls the expansion valve stepper motor. The idea is to synchronize the operation of the variable displacement AC compressor and the electronic expansion valve, to maintain constant pressures, and therefore raise efficiency. Keep in mind that the level of efficiency arrived at with an HVAC electronic expansion valve is far greater than with a regular thermostatic valve. As the stepper motor controls the aperture of the expansion valve, the stroke of the variable displacement compressor also changes accordingly. The main goal is to increase or decrease the load on the engine. If you're standing at idle, why would you want to put a big load on the engine? That's why all these newer, modern, and advanced systems are being deployed. Since the expansion valve has a direct effect on refrigerant pressure, the fine control of the stepper motor coils also has a huge effect on refrigerant pressure. In addition, flash gas in the liquid line is less damaging to the operation of the system, because the relatively large port and large stroke of the HVAC electronic expansion valve allows it to open wide, purge the flash gas, and then re-establish the desired superheat. The advantages of the HVAC electronic expansion valve are clear, but since the valve is an electric component, it requires some form of electric or electronic control. Although electric, the HVAC electronic expansion valve is still an expansion valve. Controllers allow the HVAC electronic expansion valve to do its job by measuring two components, pressure and temperature. Standard calculations for air conditioning are all the same, whether done by a technician or an electronic computer. The pressure in the suction line, just after the evaporator, is measured. This pressure is converted to a temperature by the use of a pressure-to-temperature programmed lookup chart for the refrigerant used, often RAM-UR 134A. This temperature is compared with the actual temperature measured on the suction line, also near the outlet of the evaporator. The difference between these two temperatures is the operating superheat. There are differences in how all this is accomplished, but the principle is the same. The actual programming algorithms used to control modern electronic HVAC systems are somewhat complex, but do the best job at controlling refrigerant and cooling the incoming air. With some knowledge and training you'll be able to tackle almost anything these systems throw at you. Knowledge is the key to fixing these systems.